Resistance. So what is resistance? Now, let's remind ourselves, current is a flow of charge carried by electrons, and the electrons have to pass through a lattice of metal ions, which are all vibrating. So there's a lot of collisions. Now the collisions resist the flow of the electrons. So what effect do you think an increase in temperature will have? Now, an increase in temperature will increase resistance because the ions in the metal wire, in the conductor, vibrate more, so the electrons collide more often. So the higher the temperature, the greater the resistance. Now, the thicker the wire, the less the resistance. The reason why is because there are more routes in a thicker wire for the electrons to find their way round. So this picture represents a copper wire. Those brown blobs are the metal ions, which are all vibrating, and the yellow blobs are the electrons, which are trying to pass. So the greater the temperature, the greater the collisions, and the more difficult it is for the electrons to pass. Resistance is measured in ohms, that funny symbol. R equals V over I, where resistance is measured in ohms, equals V, the potential difference measured in volts, over I, which is the current measured in amps. And this equation is on your physics equation sheet, and I've put it into a triangle again. Now in the exam you often get a current PD graph. Now this shows how the current through a component varies with the PD across it. And you can use this to calculate the resistance of the component. It shows that the greater the PD, the greater the current. And if it's a straight line, then the resistance of the wire is constant. If it's a steep gradient, then the resistance is low. Now, Ohm's law states that the current through a wire at constant temperature is directly proportional to the PD across it. You need to learn that definition. So here's a current PD graph. So have a go at these questions. The red and green lines represent two different wires. So what does the gradient of the green line tell us about the wire's resistance compared to the red line? And then calculate the resistance for each. Use the correct equation. So here you can check your answers.